The roof groaned under 3 feet of wet snow, but Augustin Leblanc sat calmly by his fire, listening to the wind tear at cabins up and down the ridge. By morning, his would be the only structure left standing, and the technique everyone had mocked as wasteful would become the standard across the northern Rockies. Before we continue, let us know where you're watching from, and if stories of frontier ingenuity speak to you, hit that subscribe button, because tomorrow's tale is even more remarkable than this one. The temperature dropped to 20 degrees below zero on the night of December 14, 1836. Inside the small cabin they shared on a ridge in what would later become northwestern Montana, Augustin Leblanc and Émile Deschamps sat close to their fire, playing cards with a worn deck Émile had carried from Quebec 3 years earlier. Outside, wind drove snow horizontally across the mountainside, piling drifts against anything that interrupted its path. The storm had been building for 2 days, nothing unusual for mid-December in the Rockies, just another test of preparation and patience that every trapper accepted as the cost of winter in beaver country. Around midnight, they heard a sound that cut through the wind's constant howl. A sharp crack, like a rifle shot, followed by splintering wood and a man's shout. Augustin stood immediately, moving to the door. Émile grabbed his arm, shaking his head. Going out in a blizzard at night was suicide. They had no way to know what had happened, or where the sound had come from, and stumbling around in whiteout conditions would kill them as surely as any disaster that had befallen their neighbor. They sat back down, but neither man touched the cards again. They simply waited, listening, wondering whose cabin had just failed and whether the occupant had survived. Morning revealed the answer. The storm had passed by dawn, leaving the ridge buried under 18 inches of fresh snow. Augustin and Émile made their way along the trapline trail that connected the scattered cabins in their loose community. Half a mile south, they found Jacob Weiss standing in front of his collapsed structure, staring at the wreckage. The entire roof had caved in on the north side, and one wall showed a massive split running vertically through 3 logs. Jacob was alive because he had been sleeping on the south side of the cabin when the failure occurred. He had managed to crawl out through the damaged wall, but everything he owned was buried under snow and splintered logs. Augustin examined the failure point while Émile helped Jacob salvage what he could. The split logs told a clear story. Water had penetrated the gaps between logs throughout the previous spring and summer, seeping into the wood itself. When temperatures dropped and that moisture froze, it expanded, creating pressure inside the log fibers. The process had repeated through multiple freeze-thaw cycles during autumn, each one driving cracks deeper into the wood. When the heavy snow load hit the weakened structure, the logs simply gave way. The cabin had been destroying itself slowly for months before the storm delivered the final stress that caused catastrophic failure. Jacob survived because of luck, nothing more. He lost his pelts, his supplies, his tools, and nearly his life. He would have to rebuild, but first he would have to spend the rest of winter living in another trapper's already crowded cabin, eating another man's food, burning another man's firewood, and trying to salvage enough credit to continue trapping come spring. For a mountain man, this kind of loss was often the end of a career. Augustin helped Jacob that day and the next, and through the following week as they constructed a crude temporary shelter. But something had changed in how Augustin looked at cabins. He started noticing things he had always ignored before. Spring came late to the Montana Rockies in 1837. Snow persisted through mid-April, melting reluctantly under weak sunlight that barely warmed the frozen ground. Augustin and Émile had survived the winter comfortably enough in their cabin, trapping sporadically during breaks in the weather and processing the pelts they had accumulated before the deep cold set in. They had been partners for 3 seasons, a good arrangement built on compatible temperaments and complementary skills. Émile was better at reading animal sign and setting traps. Augustin was better at preparing pelts and managing supplies. Together, they made a living that was neither spectacular nor desperate, just steady work in dangerous country. The spring winds arrived with sudden violence in late April. For 3 days, gales tore across the ridge with force that made walking difficult and working impossible. They stayed inside, playing cards and waiting for the weather to settle. On the second night, Augustin heard a sound he recognized from Jacob's cabin collapse, that distinctive crack of wood failing under stress. He grabbed a lantern and checked the interior walls, running his hands along the logs, looking for damage. What he found troubled him more than a dramatic break would have. The chinking between logs, the mixture of mud and moss they had packed into every gap when they built the cabin 2 years earlier, was gone in multiple places. Wind had simply scoured it out, leaving openings wide enough to push his fingers through. Cold air poured through these gaps, and when he held the lantern close, he could see daylight. The cabin they had considered solid was actually full of holes that wind and weather exploited with methodical efficiency. Worse, water had clearly been penetrating these gaps. Several logs showed darkening that indicated moisture damage, the same early stage of rot that had preceded Jacob's catastrophic failure. Emile examined the damage the next morning and shrugged. Every cabin needed re-chinking after winter. It was routine maintenance. Nothing concerning. They would gather fresh mud when the ground thawed, mix it with new moss, and pack the gaps. The cabin would be fine for another season. Augustin agreed outwardly, but felt growing unease he could not quite articulate. The problem was not just that chinking failed. The problem was that chinking always failed. Every cabin he had ever seen or lived in required constant re-chinking. The gaps between logs were permanent weaknesses that could be temporarily filled but never truly sealed. Wind, rain, freezing, thawing, settling, and simple time guaranteed that those gaps would always reopen. Trappers accepted this reality because no alternative existed. You built with notched logs because that was how log cabins were constructed. You chinked the gaps because gaps were inevitable. You re-chink every spring because chinking always failed. But acceptance of tradition did not mean that tradition was optimal. Augustin began thinking about gaps differently. What if the fundamental approach was wrong? What if instead of constantly fighting to fill gaps between logs, you eliminated the gaps entirely? The question seemed absurd. Logs were round or irregular. Stacking them created gaps by geometric necessity, but the question would not leave him alone. There had to be a better method. April 18, 1837 began as an ordinary day. The spring runoff was building as snowmelt from higher elevations swelled every creek and stream. Beaver were active, repairing winter damage to their dams and lodges, which meant trap lines needed constant attention. Augustin and Emile split up that morning to cover more ground. Emile took the northern section where 3 beaver ponds clustered along a tributary creek. Augustin headed south to check traps near the main river. They planned to meet back at the cabin by mid-afternoon to process whatever pelts they had collected. Augustin returned first, earlier than expected because his traps had yielded nothing. He started a fire and began preparing their evening meal, assuming Emile would arrive within the hour. When the sun touched the horizon and his partner still had not returned, concern began building into worry. Trappers faced countless dangers, from bear encounters to simple falls on slippery rocks. When 2 men worked together, the unspoken agreement was that unexplained absence meant trouble. Augustin grabbed his rifle and headed north along the trail Emile would have followed. He found him at the 3rd beaver pond, in the water, trapped beneath a section of collapsed dam. The structure had been damaged during winter, weakened by ice and spring flooding. When Emile had approached to check a trap set near the dam's base, the entire section had given way. Logs and packed mud had fallen on him, pinning him underwater in the shallow pond. He had drowned in less than 3 feet of water, unable to free himself from the weight holding him down. Augustin pulled his partner's body from the pond and carried him back to the cabin. He sat with Emile through the night, unable to process what had happened, unable to accept that a structure built by animals had killed a man who had survived 3 winters in grizzly country. At dawn, he buried Emile on a hillside overlooking the creek where they had taken their best catches. He marked the grave with stones and stood there longer than necessary, not wanting to return to a cabin that would now be empty. That night, alone in the structure they had built together, Augustin experienced a realization that would consume him for the next year. Emile had been killed by structural failure. A dam weakened by water and weather had collapsed at the worst possible moment. But the cabin Augustin now occupied alone was also a structure weakened by water and weather. The gaps he had found weeks earlier were not minor maintenance issues. They were fundamental vulnerabilities that would eventually cause catastrophic failure. Every cabin on the ridge was slowly dying from water penetration, rot, and structural weakening. Some would fail dramatically, like Jacob's. Others would simply become uninhabitable over time. But all of them were temporary structures fighting a losing battle against the weather. The weeks following Emile's death passed in a strange fog of routine and obsession. Augustin continued trapping because stopping meant financial ruin, but his focus had shifted. When he checked trap lines, he found himself examining the cabins and camps of other trappers with new attention. The scattered community along the ridge and in the valleys below consisted of perhaps 20 men, living in structures that ranged from crude shelters to relatively substantial cabins. Augustin began visiting these sites systematically, ostensibly for social reasons, but actually conducting a detailed study of how frontier structures failed. At Thomas Millard's camp, he found a cabin where the entire north wall had separated from the corners by nearly 2 inches. The notches holding the logs together had compressed and shifted over 2 winters, creating gaps that wind exploited mercilessly. Thomas had stuffed the openings with rags and animal hides, but the fundamental structural problem remained unsolved. The cabin was slowly pulling itself apart. Pierre Fontaine's structure showed different damage. The roof leaked in multiple places despite repeated repairs. Water stains marked the interior walls, and several ceiling logs showed soft spots that indicated advanced rot. Pierre complained that he spent more time fixing his roof than trapping beaver, yet the leaks always returned. The problem was not Pierre's repairs, but the basic construction method. Bark and pole roofs covered with sod could never be truly waterproof. Water found ways through, always. Henrik Jorgensen had built the most substantial cabin on the ridge, using larger logs and more careful notching than most trappers bothered with. But even his superior construction showed the same fundamental weaknesses. The chinking between his logs, despite being recently renewed, already showed gaps where wind had begun eroding it. The corner notches, though well cut, had compressed enough to create slight settling that would worsen over time. Henrik's cabin was better than most, but it was still fighting the same losing battle against water, wind, and weather. Augustin cataloged these failures obsessively. He filled pages of a journal with sketches and notes, documenting every type of damage he observed. Patterns emerged from his documentation. Water penetration was the fundamental destroyer. It entered through gaps in chinking, through roof leaks, through any opening the structure provided. Once inside the wood, freezing temperatures turned that moisture into an expanding force that split logs from within. Wind accelerated the damage by stripping away chinking and creating pressure differentials that stressed joints and connections. Snow loads added weight that exposed any structural weakness. Traditional construction methods created inherent vulnerabilities that could be delayed but never eliminated. Notched corners compressed and shifted. Mud chinking eroded and cracked. Bark roofs leaked. Every standard technique accepted these problems as inevitable consequences of building with logs. Trappers spent their lives performing maintenance that never truly solved the underlying issues, just postponed the eventual failure. Most men accepted this reality because they knew no alternative, but Augustin had become convinced that alternatives must exist. Somewhere between traditional construction and perfect weatherproofing, there had to be techniques that fundamentally changed how cabins resisted the elements. Late May brought warmer weather and the annual migration of trappers toward trading posts to sell their winter's harvest. Augustin packed his pelts and made the journey to a French-Canadian trading camp on the Yellowstone River, a trip that took 4 days on horseback through mountain passes still choked with lingering snow. The camp was temporary, established each spring by traders who traveled up from St. Louis to intercept trappers before they made the longer journey to permanent posts. The arrangement suited both parties. Trappers got decent prices without extensive travel. Traders got first selection of premium pelts. Augustin sold his furs for a fair price, enough to buy supplies for another season. But instead of immediately purchasing goods and returning to his trapline, he lingered at the camp, watching the French-Canadian voyageurs repair their birch bark canoes. These men were craftsmen who had learned their trade from indigenous peoples, and their canoes were engineering marvels, lightweight vessels that could carry enormous loads while being portable enough for one man to carry across land. Augustin had seen these canoes before, but had never paid attention to their construction. Now, obsessed. With weatherproofing, he watched with complete focus. The voyageurs worked with birch bark harvested in large sheets, flexible but strong. They laid these sheets in overlapping patterns, each piece covering the seams of the pieces below it. The overlapping created a continuous surface with no straight-line gaps where water could penetrate. But the real innovation was how they sealed the seams. They used pine resin, heated until it became liquid, then mixed with animal fat to maintain flexibility when it cooled. This mixture was applied to every seam, every edge, every junction where two pieces of bark met. When it hardened, it created a waterproof seal that was both flexible and incredibly durable. Augustin approached one of the craftsmen, a weathered man named Baptiste, who spoke French with an accent that mixed Quebec origins with indigenous linguistic influences. He asked questions about the bark, when to harvest it for maximum flexibility, how to cure it, how to prepare the resin mixture. Baptiste answered readily, accustomed to trappers showing curiosity about canoe construction. Most men wanted to learn repair techniques for their own vessels, but Augustin's questions went deeper, focusing on principles rather than specific canoe applications. Why did overlapping work better than edge-to-edge joining? Baptiste explained that overlapping distributed stress across a larger area and eliminated single failure points. If one section damaged, the overlap prevented the damage from propagating. Why mix fat with pure resin? Pure resin became brittle in cold weather and would crack. The fat kept it slightly flexible, allowing it to expand and contract with temperature changes without losing its seal. How long did such seals last? Baptiste shrugged. A well-made canoe could serve for years before needing major repairs, far longer than any sewn or tied construction method. Augustin left that conversation with his mind spinning. The principles the voyageurs used for canoes could apply to cabins. Overlapping barriers instead of edge-to-edge joins. Flexible sealants instead of rigid mud. Creating continuous surfaces that shed water rather than channeled it into gaps. The specific application would differ, but the engineering philosophy was sound. A cabin could be waterproofed using the same principles that made canoes watertight. The question was not whether it would work, but how to implement it using materials and methods practical for a structure that did not need to float. Augustin returned to his ridge in early June with supplies for the season and materials that puzzled the trader who sold them. Instead of the standard purchases, powder, lead, coffee, salt, and tobacco, Augustin bought items that made no obvious sense for a trapper. He purchased a small draw knife, a specialized woodworking tool used for shaping and smoothing wood. He bought a quantity of pine sap cakes, concentrated resin that trappers occasionally used for waterproofing boots, but rarely in large amounts. He acquired several coils of rawhide cord and a collection of wooden pegs that the trader had intended for tent construction. Back at his cabin, Augustin began experimenting. Summer was the season for maximum trapping effort, when beaver pelts were poorest quality but could still be taken for minor profit. Most trappers worked dawn to dusk during summer months, building up supplies and cash reserves for the harder seasons ahead. Augustin worked his trap lines, but without the intensity or focus that had characterized previous summers. His mind was elsewhere, occupied with problems of bark and waterproofing. He began testing different tree species for bark quality. Pine bark was thick but inflexible and prone to cracking when bent. Cedar bark was flexible but too thin to provide substantial protection. Spruce bark had good thickness but irregular texture that made tight fitting difficult. Birch bark was ideal, flexible, and smooth, but birch trees were not abundant in his immediate area, and harvesting large quantities would require extensive travel. The timing of harvest mattered enormously. Bark removed in early summer when sap flow was high separated easily from the trunk but was too moisture-laden and would warp severely as it dried. Bark taken in late summer separated with more difficulty but had better structural stability. Augustin filled his journal with observations about bark characteristics, seasonal variations, and curing methods. He experimented with different drying techniques, some involving sun exposure, others using smoke, still others simply allowing time and air circulation to reduce moisture content gradually. The resin mixture required equal attention. Pure pine resin was too brittle. Mixed with too much fat, it never fully hardened. The ratio needed precise calibration, and that ratio changed depending on the resin's age and the type of fat used. Bear fat produced different results than deer tallow. Fresh resin behaved differently than resin that had aged for months. Augustin conducted dozens of small tests, applying different mixtures to bark samples and exposing them to sun, rain, and temperature variations. He needed a sealant that would remain waterproof through winter's extreme cold and summer's heat, that would flex without cracking, and that would adhere permanently to both bark and wood. Other trappers noticed his strange activities. When visitors stopped by his cabin, they found him scraping bark samples or heating resin mixtures over his fire instead of preparing pelts or maintaining equipment. Word spread that Émile's death had affected Augustin's mind, that grief had driven him to obsessive, pointless activities that had nothing to do with survival or profit. Some felt sympathy. Others felt contempt for a man who was wasting the productive season on foolishness. But Augustin barely noticed their opinions. He was learning principles that would change everything. By late July, Augustin had accumulated enough knowledge to begin planning actual construction. His experiments had taught him which bark worked best, how to prepare it, and how to seal it. But applying these lessons to a full cabin required more than just materials knowledge. It required rethinking the entire structure from foundation to roof, designing specifically for bark covering rather than adapting bark to standard construction. He spent 2 weeks scouting locations within reasonable distance of his current cabin. The site needed specific characteristics that traditional cabin building ignored. It needed elevation for drainage because any standing water would undermine his weatherproofing efforts. It needed clear sight lines in all directions, both for security and to minimize wind turbulence caused by nearby trees. It needed accessibility to birch groves for bark harvesting, because transporting large quantities of bark over difficult terrain would be impractical. And it needed southern exposure for maximum sunlight, which would help keep snow loads manageable and would make the cabin more comfortable during short winter days. He found the right location on a slight rise 300 yards from his current cabin, positioned where the ridge flattened into a small plateau. The ground was rocky enough to ensure good drainage, but not so rocky that foundation work would be impossible. A stand of birch trees grew along a creek bottom, quarter-mile to the north. The site had no nearby trees tall enough to fall on the cabin during storms, but the forest was close enough to provide wind protection without creating turbulence. Augustin began by clearing the site completely, removing not just trees but also stumps, large rocks, and any vegetation that would interfere with construction. Traditional cabin building accepted uneven ground and worked around obstacles. Augustin wanted a level base that would prevent any settling or shifting that might stress his bark covering. He spent 3 full days just preparing the ground, using a mattock to break up rocks and a shovel to level irregularities. The cabin dimensions required careful calculation. Too large, and the bark covering would require more material than he could practically harvest and install. Too small, and the interior would be cramped and inefficient. He settled on dimensions of 16 feet by 14 feet, slightly larger than his current cabin, but still manageable for one man to build and cover. The wall height would be 7 feet, tall enough to stand comfortably inside, but not so tall that bark installation would require elaborate scaffolding. He designed the roof with bark in mind. Traditional cabin roofs were nearly flat, just enough pitch to shed water slowly, but bark covering would work better with steeper pitch that allowed both water and snow to slide off quickly. He planned for a roof angle of approximately 30 degrees, steep enough for good shedding, but not so steep that construction would be difficult. The eaves would extend 2 feet beyond the walls, protecting the bark-covered walls from direct rain and providing covered space for storing firewood. Every design decision considered the bark covering as integral to the structure rather than an addition to completed construction. This was not a standard cabin with bark added. This was a cabin designed from the beginning to be bark-covered. August brought the serious work of construction. Augustin began by creating a proper foundation, something most trappers considered unnecessary labor. He dug a shallow trench around the cabin's perimeter, roughly 8 inches deep, following the 16 by 14-foot dimensions he had planned. Into this trench he placed flat rocks, carefully selected for size and shape, creating a level base that would support the log walls and prevent ground moisture from wicking into the wood. The rock foundation took 5 full days to complete, time that seemed wasteful to any trapper who passed by and saw the effort being invested before a single log was laid. The logs themselves required equal obsession. Augustin spent 2 weeks selecting and cutting trees for the walls. He rejected any log with significant taper, excessive knots, or irregular grain. He wanted logs as uniform as possible, approximately 10 inches in diameter throughout their length. Most trappers used whatever trees were convenient, accepting variations in size and straightness as inevitable compromises. Augustin walked miles through the forest, marking specific trees that met his standards, then spent days felling them and hauling them to his construction site, using a horse he had purchased specifically for this purpose. Once the logs were on site, the real work began. Using his draw knife, Augustin stripped every log completely, removing all bark and shaping the surface until it was smooth and uniform. The process was backbreaking. Each log required hours of careful work, shaving away irregularities, creating surfaces that would fit together with minimal gaps. His hands blistered, then calloused, then blistered again. Other trappers who saw him working thought he had lost his mind entirely. Why spend hours smoothing logs that would be stacked and covered anyway? The answer was precision. Bark covering would only work if the underlying structure was sound and uniform. Gaps between poorly fitted logs would create voids behind the bark where moisture could accumulate and rot could begin. The corner construction departed from tradition in subtle but important ways. Augustin used standard saddle notches to join the logs, a proven technique that he saw no reason to abandon. But he reinforced each corner with wooden pins driven vertically through multiple logs, creating rigid connections that would resist the settling and compression that had destroyed Jacob's cabin. The pins were hidden inside the notches, invisible once construction was complete, but they fundamentally changed how the corners would behave under stress. Instead of each log resting independently on the one below, the pinned corners created unified structural units that distributed weight across multiple logs simultaneously. Wall construction proceeded slowly through late August and early September. Where an experienced crew could raise a standard cabin in 4 or 5 days, Augustin worked alone and with meticulous care that made speed impossible. Each log was fitted, adjusted, refitted, and finally secured only when gaps were minimized to the absolute smallest dimensions his skill could achieve. He did not use traditional chinking at all. The gaps that remained were tiny, far smaller than standard construction produced, and he left them empty, knowing the bark covering would seal them from outside. By mid-September, the basic log structure stood complete, a cabin that looked almost normal except for its unusually smooth walls and the extended eaves Augustin had built into the roof frame. Late September marked the beginning of bark harvest, the most critical phase of Augustin's entire project. Everything he had learned through summer experimentation now needed to be applied at scale. He needed enough bark to cover approximately 900 square feet of wall surface, plus additional material for repairs and mistakes. That translated to bark from roughly 30 mature birch trees, a substantial harvest that would require weeks of careful work. Augustin began by scouting the birch groves he had identified months earlier. Not every birch tree was suitable. He needed trees at least 12 inches in diameter with relatively smooth bark, free of major scars or disease damage. The bark needed to be thick enough to provide substantial protection, but not so thick that it became inflexible. He marked suitable trees with a knife, creating a mental map of where each section of bark would come from and planning his harvest route to minimize unnecessary travel. The actual harvest required techniques he had learned partly from the voyageurs and partly from his own experimentation. Using a sharp knife, he made vertical cuts through the bark from ground level to roughly 8 feet high, the maximum height he could comfortably reach. Then he made horizontal cuts at top and bottom, creating rectangular sections. Separating the bark from the trunk required patience and careful prying. Work too aggressively, and the bark would tear. Work too slowly, and the bark would begin drying and would separate less cleanly. He used a flat wooden wedge, gradually working it between bark and wood, lifting the bark away in sheets that were roughly 6 to 8 feet long and 2 to 3 feet wide when unrolled. Each tree yielded 2 or 3 usable sections of bark. After removing the bark, Augustin carried it back to his construction site where he had created a covered area for curing. The bark needed to dry partially, but not completely. Too wet, and it would mold or rot before installation. Too dry, and it would become brittle and crack when handled. He stacked the bark sheets with wooden spacers between them, allowing air circulation while preventing warping. Small stones weighted the edges to keep them from curling as moisture content decreased. The harvest continued for 3 weeks. Augustin worked dawn to dusk, moving methodically through the birch groves, taking only what he needed and leaving younger trees untouched for future growth. His respect for the resource was not sentimental, but practical. This grove might need to supply bark for future projects or repairs, and destroying it through careless harvesting would be short-sighted. Other trappers who encountered him during this work stopped asking questions. His obsession was now so complete, so obviously consuming, that conversation seemed pointless. They simply shook their heads and continued to their own work, leaving the barkman to his incomprehensible project. By mid-October, Augustin had accumulated sufficient bark and had refined his installation plan. The bark sheets were cured to optimal flexibility, the resin mixture was prepared in quantity, and the underlying log structure was ready to receive its protective covering. The weather was cooling rapidly, and first snow would arrive within weeks. He needed to complete the installation before serious winter weather made outdoor work impossible. The bark installation began on October 16, 1837, and would consume the next 5 weeks of Augustin's life. He had developed his technique through small-scale experiments, but applying it to an entire cabin presented challenges that could only be solved through actual execution. The fundamental approach was simple in concept, but demanding in practice. Vertical bark slabs would be installed in overlapping courses, starting at ground level and working upward, with each course covering the seams of the course below it, creating a continuous weather barrier with no straight-line paths for water penetration. Augustin began on the south wall, which received the most sun and would be the most visible test of his method. He started by preparing the first bark section, trimming it to uniform width, and checking for any damage or weak spots that might cause failure. Using wooden pegs he had whittled during evening hours throughout the summer, he attached the first vertical bark slab directly to the logs, driving pegs through the bark and into the wood beneath. The pegs were spaced roughly every foot vertically, providing enough attachment points to hold the bark securely without using so many that the bark's integrity was compromised. The overlap between adjacent bark sections was critical. Too little overlap, and gaps might develop as the bark aged and shifted. Too much overlap, and the bark covering would become unnecessarily thick and heavy. Augustin settled on an overlap of approximately 4 inches, enough to ensure continuous coverage while keeping the overall bark thickness manageable. Each new section was positioned to cover the edge of the previous section, and pegs were driven through both layers where they overlapped, creating a unified surface. The resin sealant came next. Using a flat wooden paddle, Augustin applied his pine resin mixture to every seam, every overlap, and every peg penetration. The mixture was warm enough to flow smoothly, but not so hot that it would run excessively. He worked methodically, ensuring complete coverage of any junction where water might potentially penetrate. The resin, mixed with bear fat in proportions he had determined through extensive testing, remained flexible enough to accommodate minor movement, but hard enough to create a genuine waterproof barrier. Progress was slower than Augustin had anticipated. Each wall section required measuring, trimming, test fitting, final installation, and sealing. Weather complicated the work. Cold mornings made the resin difficult to apply, requiring him to keep it warm over a small fire. Rain forced delays because the bark needed to be dry for the resin to adhere properly. Wind made handling large bark sections difficult, requiring him to work only during calm periods. By the end of October, he had completed only the south wall. 3 walls remained, plus the more complex roof installation. Other trappers preparing for winter saw Augustin's partially bark-covered cabin and openly mocked the effort. Pierre Fontaine rode by one afternoon and called out that Augustin was building the ugliest cabin in the territory. Thomas Millard suggested that Emil's ghost would be ashamed to see his former partner wasting time on foolishness. Augustin ignored them. He was not building for aesthetics or approval. He was building to survive. November brought the first serious cold, temperatures dropping below freezing at night and remaining cold enough during the day that Augustin's resin mixture required constant reheating to maintain workability. He had completed 2 walls by the first week of November and was making steady progress on the third when Henrik Jorgensen stopped by with genuine curiosity rather than mockery. Henrik was the most skilled builder among the ridge trappers, and unlike the others, he recognized that Augustin's obsessive methods had underlying logic, even if the specific applications seemed extreme. Henrik examined the completed bark covering carefully, running his hands over the smooth surface, testing the overlaps, checking the resin seals. He asked questions that demonstrated actual understanding of construction principles. Why vertical installation instead of horizontal? Augustin explained that vertical orientation allowed water to run straight down without encountering horizontal seams that would channel moisture behind the bark. Horizontal installation would create ledges where water could accumulate and eventually penetrate. Why overlap from the sides instead of shingling from bottom to top like roof construction? Because walls faced different water dynamics than roofs. Roof water ran consistently downward. Wall water could be driven sideways by wind, and side overlapping provided better protection against wind-driven rain. Henrik nodded slowly, processing the explanations. He pointed out that the bark covering added significant weight to the structure. Was Augustin confident the walls could support it? Augustin walked Henrik to the corners and showed him the hidden reinforcement pins that most observers had not noticed. The corners were not relying on simple notch compression. They were structurally unified, capable of supporting far more weight than standard construction. Henrik examined the pinned corners with the appreciation of someone who understood engineering, even if he had never formally studied it. The conversation shifted to broader philosophy. Henrik asked the question that others had mocked but never seriously engaged with. Was all this effort actually worth it? Augustin's answer was direct. Every cabin on the ridge was slowly dying from water penetration. Chinking failed constantly. Logs rotted from moisture trapped between them. Roofs leaked despite repeated repairs. Trappers spent their lives performing maintenance that never solved the underlying problems, just delayed inevitable failure. Henrik could not dispute this because his own cabin, despite being the best-built structure in the area, suffered from the same issues. What Augustin was attempting was not decoration or paranoia. It was fundamental rethinking of how cabins resisted weather. Traditional construction accepted that water would penetrate and focused on minimizing the damage through constant maintenance. Augustin's approach eliminated penetration entirely by creating a continuous barrier that water could not cross. The bark covering was not an addition to a standard cabin. It was a different construction philosophy that treated weatherproofing as the primary design consideration rather than an afterthought addressed through chinking. Henrik understood immediately. The question was not whether Augustin's method was excessive. The question was whether it would actually work. Theory was interesting, but frontier survival required proven performance. Augustin acknowledged this completely. His cabin was untested. It might fail in ways he had not anticipated, but standard construction failed in ways that were completely predictable and completely unavoidable. He was choosing uncertain innovation over certain deterioration. Henrik left that afternoon with visible respect for what Augustin was attempting, even if he remained skeptical about the outcome. Word of Henrik's visit spread through the trapping community. If Henrik Jorgensen thought the Barkman's cabin had merit, perhaps it was not complete insanity after all. The first substantial snowfall arrived on November 22nd, 3 inches of heavy, wet snow that clung to everything and signaled winter's serious arrival. Augustin had completed 3 walls by that point, with only the north wall and the roof remaining. The north wall went faster than the others because he had refined his technique through repetition and because desperation added speed to his work. Winter was no longer approaching. It had arrived, and working in freezing conditions was infinitely harder than working in autumn weather. He finished the north wall on December 2nd, working through a light snowfall that made the bark slippery and the resin nearly impossible to apply smoothly. The walls were now completely covered, creating a cabin that looked profoundly strange compared to every other structure in the territory. The smooth bark exterior, dark brown with lighter patches, where different trees had provided material, gave the cabin an organic appearance that seemed more grown than built. The extended eaves added to the unusual profile. From a distance, the structure looked almost like a massive tree stump, cylindrical and seamless. The roof required different treatment than the walls. Augustin had initially considered bark covering the entire roof surface, but the pitch and the weight considerations made that approach impractical. Instead, he used traditional roof construction, pole rafters covered with split planks, then layered birch bark over the planks in overlapping courses like large shingles. Over the bark, he applied his resin mixture more liberally than on the walls, creating a thick, waterproof coating. Finally, over the resin, he laid sod in the traditional manner, living earth and grass that would root and create a living roof. The multiple layers made the roof extraordinarily heavy, but the reinforced wall structure supported the weight without difficulty. More importantly, the layered construction created exceptional insulation. The air gaps between layers, the bark itself, and the sod covering combined to create a roof that would retain heat far better than standard construction. Augustin completed the roof on December 8th, nearly 2 months after beginning the bark installation. Moving into the completed cabin felt surreal. Augustin had lived in multiple cabins during his years in the mountains, but this structure felt fundamentally different the moment he closed the door behind him. The silence was the first thing he noticed. Standard cabins always had ambient noise from wind, finding gaps and whistling through chinking. This cabin was silent except for the fire crackling in the fireplace. The air was still, with no drafts moving through the interior. When he lit a candle and walked the perimeter, holding it near the walls, the flame did not flicker. There were no air currents, no invisible gaps bleeding warmth to the outside. That night, temperatures dropped to 15 degrees below zero. Augustin maintained a modest fire, less wood than he would normally burn. By morning, the interior remained comfortably warm. He had used perhaps half the firewood a normal cabin would require. The bark covering was not just keeping water out. It was keeping heat in with efficiency he had not fully anticipated. The cabin's performance through December exceeded even Augustin's optimistic projections. Daily temperatures ranged from 10 degrees below zero to occasionally rising just above freezing during midday sun. These were normal early winter conditions, cold, but not the extreme cold that would arrive in January and February. Standard cabins required constant fire tending and burned enormous quantities of firewood to maintain barely tolerable interior temperatures. Augustin found himself comfortable with a fire that would have left a normal cabin freezing. The physics behind the performance were straightforward but remarkable in practice. Standard log cabins lost heat through 3 primary mechanisms. Direct air infiltration through gaps accounted for perhaps 40% of heat loss. Conduction through the logs themselves, especially where logs contacted each other and created thermal bridges, accounted for another 30%. Radiation through gaps and thin spots handled the remaining 30%. Augustin's bark covering had eliminated the first mechanism entirely and significantly reduced the third. The result was a cabin that retained heat with efficiency unprecedented in frontier construction. Visitors noticed immediately. Thomas Millard stopped by in mid-December and commented that Augustin's cabin felt like a room in a proper house, not like a mountain cabin at all. Pierre Fontaine, whose leaky cabin required him to burn wood constantly, asked directly how much firewood Augustin was using. When Augustin estimated he was burning perhaps half his normal consumption, Pierre's skepticism showed clearly on his face. It was not possible for a log cabin to be that efficient, yet the evidence was undeniable. Augustin's woodpile, which should have been significantly depleted after 3 weeks of cold weather, remained largely intact. The bark covering also proved its worth during snowstorms. When snow fell, it did not accumulate in gaps or create pressure points where it could melt and refreeze. The smooth bark surface allowed snow to slide off gradually, and the steep roof pitch Augustin had designed meant that even heavy snow loads did not persist. After storms that left other cabins buried under snowdrifts that reached halfway up their walls, Augustin's cabin shed its snow burden naturally, maintaining clear walls and reducing the structural stress that plagued standard construction. But Augustin remained cautious about declaring success. December weather, while cold, was not the true test. The extreme cold of deep winter, the heavy snow loads of January and February, and the spring thaw that would test waterproofing under maximum stress all lay ahead. His cabin had proven itself under moderate conditions, but survival in the mountains required performance under the worst conditions nature could deliver. Other trappers were beginning to pay serious attention. The mockery had not entirely disappeared, but it had shifted. Men still questioned whether the enormous time investment was worthwhile, but they could no longer dismiss the results as pointless. Henrik Jorgensen visited twice more in December, each time examining different aspects of the construction and asking detailed questions about techniques. Word was spreading beyond the immediate ridge community. Trappers from other areas, hearing about the strange, bark-covered cabin, made detours to see it themselves. Most left shaking their heads, still convinced the effort was excessive, but a few left thoughtful, seeing possibilities they had not previously considered. Late January brought weather patterns that experienced mountain men recognized with immediate concern. The wind shifted to blow consistently from the northwest, carrying moisture from distant Pacific storms across the continental divide. Temperatures fluctuated wildly, rising above freezing during the day and plunging at night, creating conditions where snow would be heavy and wet rather than light and powdery. The sky took on a peculiar yellowish-gray color that trappers associated with major storm systems. Birds disappeared from the ridge entirely, and the few animals still active moved with urgency that suggested instinctive preparation for severe weather. Augustin had experienced enough mountain winters to read these signs. A significant storm was building, likely the kind that arrived once every few years, and tested every structure and every man's preparation. Most trappers on the ridge began taking standard precautions. They stocked extra firewood inside their cabins where it would remain dry and accessible, even if snow made outside movement difficult. They secured shutters and reinforced doors. They moved food supplies from exterior caches into their cabins. They checked their roofs and added support poles under any sections that seemed potentially weak. These were proven practices that had saved lives during previous major storms. Augustin's preparations were different because his cabin required different considerations. He walked the exterior perimeter carefully, examining every section of bark covering for any signs of loosening or damage. He found 3 spots where pegs had worked slightly loose, probably from the bark's minor shrinkage, as it continued curing through the cold months. He replaced these pegs with larger ones, ensuring tight connections. He checked the resin seals along every seam, applying additional sealant to 2 areas where he detected minor gaps. He examined the roof systematically, looking for any place where the layered construction might have created a weakness. Inside he arranged his supplies for potential extended confinement. A major storm could make outside movement impossible for days. He brought in enough firewood to last a week without leaving the cabin. He organized his food supplies for easy access. He filled every container he owned with water, knowing that melting snow during a storm was possible but inefficient. He prepared tinder and kindling in quantity, ensuring he could restart his fire quickly if it somehow went out. These preparations were standard, but Augustin added one element that demonstrated his engineer's mindset. He created a log of things to observe during the storm, specific measurements and observations that would tell him how his cabin performed under maximum stress. Other trappers saw these preparations and made their own assessments of what was coming. Henrik Jorgensen stopped by on January 30th and told Augustin bluntly that this storm would be the real test. If the bark covering failed under heavy snow load, or if wind found ways to penetrate the seals, Augustin would discover those failures in the most dangerous possible circumstances. Augustin acknowledged this completely. He had built his cabin based on theory and limited testing. The approaching storm would provide data that no amount of experimentation could replicate. He was confident in his engineering, but humble enough to recognize that nature might reveal flaws he had not anticipated. The storm arrived on February 1st, 1838, beginning with light snow that quickly intensified into a blizzard. The snow began falling heavily around noon on February 1st, large wet flakes that accumulated with alarming speed. Within 2 hours, visibility had dropped to less than 50 feet. Wind built steadily throughout the afternoon, reaching speeds that made the cabin's logs creak and groan under the pressure. By evening, the storm had achieved full fury, wind-driven snow creating whiteout conditions and temperatures dropping as the moisture-laden air mass was displaced by Arctic cold, pushing down from the north. Augustin sat by his fire, listening to the storm's progression and making notes in his journal about what he observed. The cabin's performance under the initial onslaught was remarkable. Despite wind that Augustin estimated at 40 to 50 miles per hour, no drafts penetrated the interior. The bark covering was holding completely, flexing slightly under the wind pressure, but not separating or allowing air infiltration. The fire burned steadily without the flickering and smoking that indicated air currents disrupting the draft. Interior temperature remained comfortable with a fire that was modest by storm standards. Augustin could hear snow accumulating on the roof, a sliding, settling sound that increased throughout the night. But the roof structure showed no signs of stress. February 2nd brought no relief. The storm continued with undiminished intensity, snow falling continuously, and wind maintaining its assault on anything that stood above ground level. Augustin ventured to open his door briefly around midday and found snow had drifted against it to a depth of nearly 4 feet. The accumulation on the roof, visible when he looked up through the brief opening, was extraordinary. He estimated at least 2 feet of heavy snow, possibly 3, adding tons of weight to the structure. Yet the roof showed no sagging, no creaking that would indicate imminent failure. The reinforced corners and the cabin's unified construction were distributing the load exactly as Augustin had intended. Through the second night, sounds from elsewhere on the ridge told a different story. Around midnight, Augustin heard a distinctive cracking sound, followed by what might have been a man's shout, though the wind made it impossible to be certain. The sound came from the direction of Thomas Millard's cabin, roughly half a mile west. Later, perhaps around 3 in the morning, another crack echoed through the storm, this time from the east where several trappers had cabins clustered relatively close together. Augustin knew these sounds. He had heard them before when Jacob's cabin failed. These were structures collapsing under loads they could not support. February 3rd brought partial clearing. The snow stopped falling around dawn, though wind continued to gust periodically. Augustin waited until mid-morning, then forced his door open against the massive drift that had accumulated. The scene that greeted him was catastrophic. Snow covered everything to depths that varied from 2 feet in wind-scoured areas to 6 feet or more where drifts had formed. The landscape was unrecognizable, familiar landmarks buried or transformed by the massive accumulation. His cabin stood intact, snow covering the roof to a depth he estimated at 3 feet, but the bark-covered walls were clear, the smooth surface having shed snow rather than allowing it to cling and accumulate pressure. Looking toward the other cabins, visible from his location, Augustin saw destruction. Thomas Millard's cabin had lost its entire roof, collapsed inward under the snow load. Pierre Fontaine's structure showed severe damage to one wall. Even Henrik Jorgensen's well-built cabin had sustained visible damage, one corner showing signs of serious structural failure. February 5th dawned clear and brutally cold, temperatures having dropped to 30 degrees below zero overnight after the storm system passed. Augustin had spent the previous day digging out his door and clearing paths to his woodpile and water source. Now he needed to assess the full extent of damage across the ridge community. He set out on snowshoes he had made years earlier, following what he remembered as the trail connecting the scattered cabins, though the trail itself was completely buried under snow that remained 3 feet deep even in relatively level areas. Thomas Millard's cabin was a complete loss. The roof had collapsed entirely, crushing everything inside. Thomas himself had survived only because he had been outside checking on his horses when the failure occurred. He had taken shelter in his small animal shed, a crude structure that had somehow remained standing despite being far less substantial than his cabin. Thomas was alive but facing complete ruin. Every supply, every tool, every pelt he had accumulated was buried under snow and splintered logs. He would need to rebuild from nothing, and winter was far from over. Pierre Fontaine's cabin had sustained damage that was severe but not total. The north wall had partially collapsed where corner compression had created a weak point that the storm's combination of snow load and wind pressure had exploited. Pierre had shored up the damaged section using poles and was living in the partially destroyed structure because he had no alternative. His situation was better than Thomas's, but still desperate. Repairing the damage in the middle of winter with limited materials would be extremely difficult. Henrik Jorgensen's cabin showed the kind of damage that Augustin had predicted affected all traditional construction. One corner had sustained serious structural failure, logs separating where the notches had compressed under the extreme load. Henrik had reinforced it from inside, using timbers as braces, but the damage was permanent. The cabin would require complete rebuilding once weather permitted. Two other trappers Augustin checked on had similar stories, damage ranging from partial roof collapses to wall failures to doors torn completely off their hinges by wind pressure. Of the 9 occupied cabins on the ridge, 7 had sustained damage ranging from serious to catastrophic. Only 2 structures had survived intact. One was Augustin's bark-covered cabin. The other was a small stone-reinforced shelter occupied by an older trapper named Wilhelm Brandt, who had built his structure partially into a hillside and reinforced it with stone walls that made it more bunker than cabin. Wilhelm's survival was due to entirely different engineering choices, but the principle was the same. Structures built with superior methods survived conditions that destroyed standard construction. Mathieu Giroux's situation was particularly dire. His cabin had collapsed completely during the second night of the storm. Mathieu had survived by sheltering under his sleeping platform, which had created a small protected space when the roof came down. He had dug himself out the next morning, hypothermic and injured, but alive. He now had nothing, no shelter, no supplies, no means to continue trapping. When Augustin found him, Mathieu was attempting to salvage usable logs from his destroyed cabin, a nearly hopeless task given the extent of the damage and the continuing extreme cold. Augustin helped him for several hours, but both men recognized the fundamental reality. Mathieu's trapping career was over unless someone helped him rebuild. Augustin made Mathieu an offer that afternoon, sitting in what remained of the destroyed cabin while wind howled across the exposed ridge. Mathieu could move into Augustin's cabin temporarily, sharing space and supplies until weather permitted. Construction of a new structure. In exchange, Mathieu would help build that new cabin using the bark covering techniques that had proven themselves during the storm. Mathieu agreed immediately, having no viable alternative, and being genuinely curious about methods that had produced the only undamaged cabin on the ridge. They began planning the new structure in early March, after the worst cold had passed, but before spring thaw made construction sites muddy and unworkable. Augustin shared everything he had learned, holding nothing back. He explained the foundation principles, the importance of uniform logs, the corner reinforcement techniques, the bark selection and curing process, and the installation methods that created weatherproof seals. Mathieu listened with the focus of a man whose life had been saved by understanding these principles. He asked detailed questions about every step, wanting to comprehend not just the procedures, but the underlying reasoning. Site selection came first. Mathieu chose a location near his original cabin, but on slightly higher ground with better drainage. They cleared the site together, then began the foundation work. Augustin demonstrated how to create a level rock base that would prevent settling and moisture wicking. Mathieu had built 2 cabins previously using standard methods that ignored foundations entirely. Watching Augustin work, he understood immediately why his previous structures had developed problems. Without proper foundations, cabins settled unevenly, creating stresses that accumulated over time and eventually caused failure. Log selection and preparation consumed 3 weeks. Augustin was insistent about quality, rejecting logs that Mathieu would have considered acceptable. They needed uniform diameter, straight grain, and minimal knots. Each log required complete bark removal and careful shaping to create smooth surfaces that would fit together precisely. Mathieu's initial impatience with this meticulous approach faded as Augustin explained how gaps between poorly fitted logs created the moisture penetration points that destroyed cabins from within. By the time they had prepared enough logs for the walls, Mathieu had internalized the philosophy that extra time during construction prevented catastrophic problems later. The actual wall raising took 2 weeks, far longer than standard construction, but producing results that Mathieu could see were superior. The reinforced corners, the tight log fitting, the structural integrity of the unified framework, everything was built to standards that exceeded normal frontier construction by significant margins. Other trappers who stopped by to observe the work saw 2 men building with obsessive care that seemed excessive until they remembered which cabins had survived the February storm and which had not. Bark harvesting and installation occupied most of April. Augustin taught Mathieu how to identify suitable trees, when to harvest for optimal bark quality, how to cure the material properly, and how to install it in overlapping courses that created continuous weather barriers. The work was tedious and demanding, requiring patience that Mathieu had never previously applied to construction projects. But watching his new cabin take shape, seeing the smooth bark covering emerge section by section, Mathieu understood he was learning techniques that would keep him alive through future winters that would kill men living in standard cabins. Mathieu's cabin was completed in early May 1838, the first structure built by someone other than Augustin using bark-covering techniques. It stood solid and weatherproof, a testament to methods that had seemed insane months earlier but now represented proven engineering. Word of the 2 bark-covered cabins spread through the scattered trapping communities across the northern Rockies. Some trappers remained skeptical, unwilling to invest the additional time and effort required. But others, particularly those who had experienced cabin failures or who had survived the February storm in damaged structures, began adopting variations of Augustin's methods. The spread was organic and gradual, not driven by any promotional effort. Augustin never claimed credit or tried to profit from his innovation. He simply continued trapping and living in his superior cabin, sharing his techniques freely with anyone who asked. Henrik Jorgensen rebuilt using partial bark covering, applying the technique to his most vulnerable walls while leaving others traditionally chinked. Thomas Millard, starting completely over after his total loss, built a smaller cabin but bark-covered it entirely, having learned through catastrophic failure that standard methods were inadequate. Over the next 5 years, perhaps 24 cabins across Montana and Wyoming territories were built, using full or partial bark-covering techniques. The trapping community began referring to these structures as Leblanc cabins, a name Augustin neither encouraged nor rejected. He found mild amusement in having a construction method named after him when he had simply been trying to survive after watching his partner die. The innovation had never been about legacy or recognition. It had been about solving the fundamental problem of water penetration that killed men slowly through structural failure. The Rocky Mountain fur trade was collapsing by the early 1840s. Beaver populations had been devastated by decades of intensive trapping, and fashion had shifted away from beaver felt hats toward silk, destroying the market that had driven the entire mountain man era. Trappers began leaving the wilderness, seeking opportunities elsewhere. Augustin left in 1843, selling his trap line to a younger man, and traveling to the Oregon Territory where land was available for settlement. He established a small farm near the Willamette River, married a widow with 2 children, and lived quietly for the next 28 years. But the cabins remained. Settlers moving west discovered abandoned bark-covered structures and immediately recognized their superior construction. Some were reoccupied and maintained. Others served as way stations for travelers crossing the mountains. A few survived into the 20th century, long after the men who built them had died and been forgotten. The technique itself persisted longer than the fur trade that had spawned it. Homesteaders and miners adapted bark-covering methods to their own needs, creating variations based on available materials and local conditions. Augustin Leblanc died in 1871 at age 59, buried in a small cemetery outside Salem, Oregon. His gravestone identified him simply as a farmer and family man. Nothing mentioned his years in the mountains or the innovation that had saved lives across the northern Rockies. But on remote ridges and in isolated valleys, structures built using principles he had developed still stood weatherproof and solid, silent monuments to what careful thought and obsessive attention to engineering could accomplish on the American frontier.